Today, we will be going over sections 2.6 and 2.7 in your book. First, in 2.6, we'll be talking about different properties that you've probably already used in algebra class. I'll explain each of these properties and when you would use them as a justification for a step in a proof. First, we have the reflexive property. The reflexive property is simply A equals A, or a number or some kind of measurement equals itself. The reflexive property seems pretty obvious, but it will be very useful to you in future proofs. To help you to remember the reflexive properties, think about what you see reflected in a mirror. You see you. The symmetric property says if A equals B, then B equals A. Symmetric tells us that if I show it one way, the other way also works if those two objects, measurements, numbers are equal. The transitive property is like a chain. The transitive property says if A equals B and B equals C, then A equals C. You have to know this part first in a proof, A equals B and B equals C, and then you can make this conclusion using the transitive property. The addition and subtraction properties of equality you use when you solve algebraic equations. So when you have an equation and you add a number to both sides of an equation, that's the addition property of equality, or as we'll write it, APOE. And if you subtract a number from both sides of the equation, that's the subtraction property of equality, or SPOE. Since subtraction is really just adding a negative to both sides, you can always use APOE and you don't have to use SPOE. However, if you're more comfortable using SPOE when you feel that you're subtracting a number from both sides, that's perfectly fine. The multiplication and division properties of equality help us to multiply a number on both sides of an equation or divide a number from both sides of an equation. Again, this helps us to solve algebraic equations. We can call multiplication property of equality MPOE and division property of equality DPOE. Again, division is really multiplying the reciprocal to both sides. So if you always want to use MPOE, that's fine. But if you feel that you're dividing a number from both sides of the equation and want to use DPOE, that is fine also. The substitution property says that if two numbers are equal, you can replace one with the other. This also works for measurements in geometry, as measurements are numerical values. And we have the distributive property. When I have a number in front of a sum or a difference in parentheses, I can multiply that number through that sum or that difference to get this. For example, if I have A times B plus C, that's the same as A times B plus A times C. Down here we have examples of reflexive, symmetric, and transitive using geometric measurements. Remember again, measurements are numerical values, which is why we can use the equal sign here. Now I would like you to pause the recording and do this Geometer Sketchpad activity. All the properties that you have learned and used so far have been properties of equality. They were only used when you had an equation or an equal sign. These three properties, reflexive, symmetric, and transitive, can also be used for congruence. Remember, measurements are equal. Objects can be congruent. Here's an example of the reflexive property. This says segment AB is congruent to segment AB, or segment AB is congruent to itself. The symmetric property says if two objects are congruent to each other, as in segment AB is congruent to CD, then we can flip that congruence statement around and say segment CD is congruent to segment AB. And the transitive property, again, works for congruence. These are the only three properties that we can use when we have congruent statements. If we want to use any of the other properties to justify a conclusion we make in a proof, we must make sure that statement is written as an equality statement.